In this video, we're going to take a look at the design of application programming interfaces. We'll describe the different types of APIs, look at the different parts of a URL, the verbs used to access the APIs, and provide some tips on how to effectively think about the design. In other videos, we'll show how to exercise the APIs for testing. We need to start here. What is an API? API stands for Application Programming Interface. You can think of it as a set of rules and protocols that allow different software applications to communicate with each other. It's kind of like a menu in a restaurant. You know what you can order, but you don't need to know how the kitchen prepares it. In our case, this is delivering data to the user without them knowing where or how the data is stored, or possibly how calculations are performed. Why are APIs important? APIs are the backbone of modern software development. They allow for the integration of different systems and services, enabling functionalities like pulling data from a server, updating records in a database, or processing payments. In short, APIs make our digital lives run smoothly. While we're focused on web APIs, there are APIs at every level of software. Operating systems provide a set of features to applications running on the operating system. Software drivers are literally the APIs that make hardware work. For instance, there's a contract between the operating system and the video card, which allows the operating system to ask the video card to display an image on a screen. Without an interface layer, this operation would be complicated and require lots and lots of collaboration between the two developers. There are two different types of APIs: REST APIs and SOAP APIs. These are the two main ones we're going to focus on. And while REST is more flexible and easy to use, SOAP is more rigid, but it offers more additional features like security. And we'll dive deeper into these two on the next slide. So the two different types of APIs that we're focused on, we have REST APIs. And this stands for Representational State Transfer. They're the go-to for most developers. They use standard HTTP methods, they're stateless, and they're easy to understand. REST is like the casual dining APIs, accessible and user-friendly. The endpoint's very readable, and it's clear what we're going after. SOAP APIs, or Simple Object Access Protocol APIs, are old-school formal APIs. They come with a set of standards and are often used in enterprise settings. Think of SOAP as the fine dining experience, more formal but with extra services like built-in security features. These APIs are much more sophisticated and require a bit more hidden and verbose coding. But in general, we get many more services. The differences between REST and SOAP APIs. So let's break it down. REST is generally easier to work with and a bit more flexible. SOAP, on the other hand, is more rigid but offers additional features like WS security. It's like choosing between a Swiss Army knife and a specialized toolkit. Each has its own set of advantages and use cases. For our purposes, we're going to focus on developing REST APIs. They're easier to understand, require a bit less logic on the back end, the server side, to unrun the request and to turn it into something useful. What is a URI? A URI, a uniform resource identifier, is basically the address you use to access a resource over the internet. It's like the GPS coordinates for a location on the web. URIs are the building blocks for any API, as they specify where the API can find the resources you're looking for. There are two types of URIs that we're interested in, URLs and URNs. A URL is what you commonly see in your web browser, like this example here, https :/learn.uark.edu. URNs are less used and are used less frequently rather, but they serve as a unique identifier for a resource regardless of its location. Here's a couple of other examples for URIs. The URI for fetching a user's profile in a REST API might look like this here. We can see right here where it gives us the example.com/students/123. This gives us the student with the ID 123. In a SOAP URI, the URL might be embedded in the XML request you send to the server. Key takeaway here, URIs are essential for directing your API request to the right place. Now, we need to talk about the parts of a URL so that it's clear on how you might put these together. The first part of the URL is the protocol. You've seen HTTP://. This defines the rules for how the data is transmitted between the client, that is a browser or your application or your code, and the server. You'll either see HTTP or HTTPS for secure connections, but there are some other protocols that are available. File, for instance, you may see file://. This is used for accessing files on your local system. Or FTP for the file transfer protocol is another protocol that's available. And you may even see a URL with a mail to. This sends a SMTP request or a simple mail transfer protocol or an email can be used with this kind of a protocol for a URL. The next part we see is the domain or host name. It translates into an IP address that points to the actual location of the server. When we test our own APIs, we'll be hosting them on the same machine we're testing from. So we'll often use the host name localhost or the IP address directly 127.0.0.1. Both refer to the local machine. Next, we get the port. The port tells the server exactly where on that domain or host name that should be answering the request. If we're expecting the default port, then it's often hidden. For instance, when you type https://google.com, you don't specify the port because it's expected to be 443. Keep in mind when we're building our API, the library we use will expose our API on port 5000. This ensures we don't accidentally answer requests to port 80 or 443 while we're in testing. In production, we would specify our protocol to listen on port 80 or 443 as expected, but by using 5000, really any port number larger than 1024, we can assure that only the traffic we want answered by our API is actually getting to it. So keep this in mind. We're going to have to specify the port 5000 when we use our URL to test our API. Once we've specified the protocol, the domain or the host name, and the port, now we get to the path. And this represents the location to the specific page or resource we want to access. This is similar to the folder structure or path on your computer, where each subfolder in the path is separated by a / and it tells the server where to find that specific resource. In the example on the top, we see the path is students, while in the lower example, the path is much more complex, with folders in subfolders all the way down to a very specific file. The top path is to a resource, while the bottom path leads to a file. It's important to note here there is not a file called student on the example.org website. It's just the endpoint where the API is served. We're going to specify this in our code, and it'll become much more obvious when we start building APIs. But this is where we begin in our code defining the route. Optionally, we will have in our URL a query string. The query string provides a set of key value pairs with an ampersand separating them. This provides more details to the server and can be used to request or pass data to the server. We're going to look at these in a minute as we consider how they're used by our tool. But one thing to see here is if there are special characters, these need to be URL encoded and can be a bit of a nightmare to decipher. Here are two examples. Spaces are encoded by %20, whereas an equal sign is encoded as %3D. And so in the example here, if we need to pass a value of hello world as one of our key value pairs, we need to encode it as hello %20 world. That way the server knows how to unpack that, turn it into a space. The same thing, if we needed to specify an equal sign for whatever reason in our value, we would have to use the %3D encoding. So keep this in mind when you're defining name value pairs, that you can't just simply send the actual text over if it includes things like special characters or spaces. And finally, and this is just for completeness, you may see a hashtag in a word. This is called a fragment, and it's used by the client side almost exclusively to navigate to a particular part of a page. This won't come into play with our API development, but for completeness, I want to make sure to provide this detail. And now that you understand all the different parts of the URL, you have a great new party trick, being able to explain URLs to your friends and break it down for them to tell them exactly what they're seeing when you type in that URL or you go surf a page on the internet. Now that we have URLs, we need to talk about the verbs we use to define the types of actions that we want to perform on a resource. You can think of the HTTP verbs as the doing words in the API world. They're like different ways you can interact with a physical object, picking it up, putting it down, moving it, so on. Let's take a closer look. The first, we're going to use these first four verbs quite extensively: get, post, put, and delete. The others that are available, we won't talk about them, are patch, head, and options. Get is like asking for a menu at a restaurant. You're requesting data from a specific resource, but you're not making any changes. It's read-only, and it's one of the most commonly used HTTP methods in API calls. And this is the default verb. So when we open up the web browser and type in a URL, the web browser makes a GET request to the server hosting the URL. We don't actually have to specify it, it's just there by default. Post requests are used when you decide what you want from the menu and tell the waiter. In API terms, you're sending data to be processed to a specific resource. This is how you create new records or initiate actions in the server. And while not always obvious, usually when you enter information into a form on a web page, hit the submit button, this results in a post request to the server. usually in code, so you don't typically see. A put request is like changing your order. You're updating an existing resource with new data. Unlike post, which can create new resources, put is idempotent. That means doing it one or more times has the same effect. Similar to post, but this is only used for updating existing items. And finally, delete. And delete is pretty self-explanatory, right? It's like canceling your order, removing a resource specified by the URI. Be careful when using it because it's destructive. On the other end, you're going to actually delete rows out of your database, or you're going to take some particular action. Again, there's three other kind of verbs, patch, head, and options, but just for the sake of this info, we're sticking to the basics. Just know that each verb has a specific role in the interaction between the clients and the servers. Now we're going to dig into each one of these verbs one by one and kind of understand how they're used. This is important because these are the endpoints that we're going to create in our code, and we need to be thinking about how they would be, how we're going to define them and use them. Get methods are really the easiest to understand. They can use paths or query parameters, and it's the default HTTP verb, so it's super easy to emulate just by opening the browser and typing in a string. Here's some examples of how we might get data from the API, which exposes a database of students and grades and courses. Notice here, the first example uses a path. We're using curly braces to note variable content. So you see here the path is defined as students, and then a particular student. And then we're asking for the courses. And finally, a particular course. Below the description, we see the example path. Students 1, so it says, get me the student with the ID of 1, get me their courses, the course with the ID of 2, and therefore give me the grade for the student, the course that has an ID of 2 for the student of 1. We can do this same operation using query parameters if you prefer. Here, if we look at it, we see we have a path of grades, right? Everything following the question mark is our query parameters, so it specifies our name value pairs. The student ID is 1 and the course ID is 2. Finally, we can use a combination of these two things. The path here is students, a particular student ID, grades, and then the question mark says we have query parameters. This is a course ID equal to 2. All of these things return the same values. There's a couple of hints in the blue box which help decide which is the right approach for us to use. You should default to query strings for optional parameters since we're using name value pairs. If one's missing, it's no problem. But if it were missing and we use the path approach, it would really kind of create a mess. Also, query strings are best for parameter values that have special characters or spaces. These don't work well with paths either, right? Use path parameters for required variables. This ensures that they're provided. And finally, when using specific parameters, it's best to be consistent. Use the same parameter names across all paths. For instance, if you have a limit parameter, then make sure it's called limit in all the paths that support it. Again, looking at the best practices for paths, here's a few examples that just kind of describe what to do and what not to do. In the first example, it shows that we're going to use query parameters, student, and then John space Smith, we want to use a query parameter rather than the alternative where we would make it part of the path, student John %20 Smith. We want to make sure that we're using the same path with the same name for the path with the parameter. And notice that in the third example, limit is an optional parameter. So we specified it as a query parameter because it's optional. That would not be a good use in the lower example where we put students / limit 10. The post verb is used to create new entities in our system. While we can use query parameters to specify the details of the post command, it's kind of uncommon, and we prefer to hide this in the body of our request, usually in JSON or XML format. In this case, we're using name value pairs in a JSON format because Python takes care of taking a dictionary, converting it to JSON very easily for us. You can notice in our code right here. The code on the right shows how this will look in the client. While a get is very straightforward, and since it's a default, it's often the easiest to test for because we can just type it in the browser and exercise the endpoint. The other verbs are a little more complex. Fortunately, we have some tools to help with testing. We'll show you one such example in another tool. But you can always write your own Python code pretty quickly to test the endpoints. We've shown you an example. This is all the code that's required here to test an endpoint of post that sends a first name, a last name, and a birth date. We didn't have to worry about dealing with URL encoding because these aren't query parameters. They're just sent as part of the data along with the post request. Again, put is a kind of a hybrid between the post and get. We need to define the target. This is done with either the path or the query parameters, like the get. And then the parts of the record to be updated are supplied in the body, like the post request. So notice here our URL, our path in our URL includes the customer we are updating, customer 1, with the ID of 1, but the values that we're updating are specified here in our payload, which are sent as part of the data request. Notice this is where carefully thinking about our API before writing it helps to maintain consistency and usability. Like in this case, I expect that we're going to use paths to get customer information. Then I also should use a path to put customer information. It wouldn't be consistent to switch to using query parameters to specify the customer ID when I'm ready to update it if I haven't implemented this approach with the gets, right? Finally, we have delete. And this completes our CRUD tour, our create, read, update, and now delete. Delete looks a lot like a GET request in that we use either paths or query parameters to specify the target item. And we just go ahead and make the request. So this is very similar code that we would see for the GET request. The only difference here is that we specified the delete verb in our request. As you begin to plan your API, you want to think about these few aspects. First, identify the purpose. Before you start coding, we need to know what the problem is solving. Is it for data retrieval, payment processing, social media integration? Knowing why helps you design the how. We've done a bit of this work already in our visioning document, but now we want to think about exactly the data that we're going to expose. Point 2, define the endpoints. And the endpoints are the specific functions that or methods that your API is going to expose. You can think of them as different sections on a menu, like appetizers, mains, and desserts. Each endpoint should have a clear and specific role. And when you think about the endpoints, from a REST perspective, this is really the nouns. So what are the things that we're going to expose? And then we can decide if those things need to be exposed for um, getting, that is querying them, if they need to be exposed for updating, deleting, or creating new ones. In some cases, we only are going to support a few of those verbs. In other cases, we're going to support all four of them. And if you're developing for public API, then you should definitely consider versioning. APIs evolve, and you don't want to break existing applications when you make updates. Versioning your API is like offering a new menu, keeping the old one for those that prefer it. It ensures backward compatibility. This shouldn't be too much of an issue for us because um, because you're really just going to have one version of your API, and you may be adding some endpoints to it, but typically you're not changing how those endpoints are working. If you're building a public API, then you really should consider planning for versioning in the API using headers or paths. You may see some examples of those as you work through testing some of the internet APIs. You'll see, for instance, the path includes v1.0 slash, and then the rest of the nouns that you're expecting. Another important aspect as we're planning our API, we go from planning to documenting. Documentation is like a well-trained waiter, to keep our restaurant example going. It helps us to understand what's available and how to make the best use of it. It's crucial for both internal developers and external consumers of your API. There are various tools that help you document your API, like Swagger and Postman. These tools make it easier to create, maintain, and understand your API documentation. And as you've read in the textbook, the Open API specification it can be really useful in kind of creating that API. You should include examples, be clear about any rate limits that you have, update your documentation as your API evolves. It's going to save everyone time and reduce frustration both in supporting and using your API. Quickly, the Open API specification is used for building APIs. You can think of it as a blueprint or a contract that defines how your API should behave. It standardizes documentation, allows for code generation, even helps in testing. It defines endpoints, the request and response types, and if necessary, any authentication methods. You'll start by creating the Open API document, usually in YAML or JSON format, and then you can use a whole slew of tools like Swagger or Redoc to create and display your Open API documentation. If you haven't read Chapter 5 in the textbook, you may find this helpful. There's plenty of tools that know how to use Open API documentation to format both client and server code, and can be a helpful tool for testing. So do a little bit of digging on where this is at. We're not requiring you to use the Open API format, but I think you'll find it really useful. At the very least, you need to specify your API because you'll be handing off your API to another team to use. And the last thing you want to do is be answering questions about how your API or how to use your API um, without while you're trying to work on your own front end. Finally, once your API has been planned, documented, and implemented, you're going to need to be able to test it. And you can start testing. You run your code in VS Code. We're going to show you some examples of how to build your API in one of the group assignments. But when you run your app, it will kind of run in the background. It will stand up a web server that is listening on port 5000 for requests. And you can test it using the browser for your GET functions. That's the simplest way, right? Start by using the browser specifying the path, the query parameters that are required, and hit the GET function to see it go. You can also test it using the curl command. You may have to download this if you're running Windows or on a Mac, but you can use the curl. It's a command line utility, so you specify the different tests you want to run, but what it does is it allows you to test all the verbs. So kind of you can open up Notepad, create all the different tests in Notepad you want, and then just cut and paste them onto the command line as you want to test them. That's one option. Another option, and one that we're going to show you how to use in a different video, is really kind of the preferred method. This is to use a tool called Postman. It's useful for shared and complex testing of all the verbs. It's portable, and it can even help you write the client code for Python or JavaScript, which is helpful when we start building our front ends. This is going to be really important in the next phase of the project when we put the API to use by building the front end, if you decide to use a web page for that. Anyway, so be looking forward to the video on Postman. To recap, in this video, we covered the basics of APIs, what they are, and the two different types, both REST and SOAP APIs. We looked at URLs, broke down the constituent components of a URL into protocols, ports, paths, query parameters. We looked at the HTTP verbs, which are used to specify how to interact with the endpoints defined by the URL. These verbs align with the common CRUD, create, read, update, and delete operations that we're most familiar with when we're developing applications. And finally, we gave a bit of overview on the importance of planning an API, documenting the API, and getting ready to test an API. In a future video, we'll show a bit more about implementation of the API and also how to go about testing your API.